So now that you know how to figure out the charges on ions and write their symbols, we're going to learn how to write formulas for what are called binary ionic compounds. So first of all, we want to understand what is an ionic compound. You see the word ion in there, and that's kind of important. An ionic compound is a neutral combination of one cation and one anion. Neutral is important. Okay? The word binary means that we're talking about two elements. So both ions, the cation and the anion, are going to be monatomic ions. Okay? If you remember that cations are the ones that lose electrons, well, those are metals. And the other ones, therefore the anions, gain electron, those are nonmetals. So a binary ionic compound is made from a metal and a nonmetal together. Okay? Because they're neutral, now what that means is that the number of positive charges has to equal the number of negative charges. Cations are positive, anions are negative. So the total number of positive charges on your cation has to be equal to the total number of negative charges on your anion. That's important. So, to write a formula, an ionic compound formula shows you the number and kinds of each ion in that compound. Okay? The cation is always written first. So it's always the metal part first. And since we're canceling out the charges, positive and negative charges are equal, they cancel each other out, that means that we don't have any pluses or minuses in our formula. They're gone, they're neutralized. Okay? If you need more than one ion to balance the charges, then you're going to put the number of ions that you're using as a subscript. And that goes to the lower right of the ion that it refers to. You'll see how this works as we do some examples. Okay? So here's example 1. We're going to write the formula for potassium bromide. That's the compound's name, potassium bromide. So the first thing you want to do is figure out which is the cation and which is the anion. Well, remember that the cation is written first. So the potassium is the cation. Cations are positive. They have a positive charge. Potassium has a symbol K. If you look at the periodic table and see where it is, potassium has to lose one electron to become isoelectronic to a noble gas. So it loses one electron, means it has a +1 charge. Bromide comes from the element bromine. Bromine is Br. Br needs to just gain one electron to be isoelectronic to its nearest noble gas, which means that bromine is going to get a -1 charge when it becomes the bromide ion. Okay? So now I know that the potassium ion is K+, the bromide ion is Br-. Those are my ions. I need to make sure the number of positive charges is equal to the number of negative charges. Well, in this case, they are. We have one positive and one negative. And as long as that's the case, they're equal, then I just put them together. One K and one Br. The charges are neutralized, so there's no pluses or minuses, and it's KBr. That's the formula for potassium bromide. Well, that was an easy one because the cation was +1 and the anion was -1. Well, what if the charges of the ions are different? It's pretty simple. Okay, let's take an example. We'll write the formula for magnesium chloride. So magnesium chloride, the cation for magnesium chloride is magnesium. Magnesium, if I look at the periodic table, needs to lose 2 electrons to become like a noble gas. So it's going to have a charge of +2. Chloride is from chlorine, and chloride needs to gain 1 electron to be isoelectronic to a noble gas. So chloride has a -1 charge. So there are my ions, magnesium +2 and chloride -1. The problem is that I have 2 positives but only 1 negative. And in order to make a compound, the number of positives and negatives has to be equal. Well, this is easily fixed. All I need is another chloride ion. If I have 2 chloride ions, then the total number of negative charges is 2. And so that allows me to have 1 magnesium and 2 chlorides. There's the 2 of them, and there's where I put my 2, MgCl2. That's how you do it when your charges don't initially match. You might need to use more than one of the ions to get it to work. What about aluminum oxide? Now this is a tricky one. Stop the video and see if you can figure out the formula for aluminum oxide. When you come back, we'll go through it. Are you ready? All right, aluminum oxide. The cation is the aluminum ion. Al for aluminum. We look at the periodic table, we see that aluminum needs to lose 3 electrons to be like a noble gas, so it's going to get a +3 charge. Oxide comes from the element oxygen. Oxygen needs to gain 2 electrons to be like its nearest noble gas, neon, and so it will have a -2 charge. So now I have 3 positives and 2 negatives. They don't match. They have to match in order for me to make the formula. Well, I need some more negatives because I have 3 positives but only 2 negatives, so I'm going to take another oxygen, another oxide ion. Now I have 4 negatives, but I only have 3 positives. I don't have enough positives now. Well, I'm going to have to take another aluminum ion to get some more positives in there. Well, now I have 6 positives but only 4 negatives. I'm going to need some more oxygen, another oxide. Now I have 6 negatives and 6 positives. Now the number of positive charges is equal to the number of negative charges. Now they're equal. So now I can write my formula. There are 2 aluminums, so I write Al2. There are 3 oxides, so I write O3. Al2O3 is my formula for aluminum oxide. So if you want to name ionic compounds now, it's very simple. Naming them is easier than writing their formulas, in my opinion. All you have to do is just name the 2 ions. You don't have to tell how many there are. A lot of people like to, for example, in MgCl2, they like to say magnesium dichloride because there's 2 chlorines. You don't have to do that. You don't have to do it because there's only one way that magnesium and chlorine can ever go together in an ionic compound, and it has to be 1 magnesium and 2 chlorine, so you don't have to say it. Just say magnesium chloride. Watch out for the transition metals. Remember that transition metals have multiple possible positive charges, and that means you have to, in the name of the compound, you have to tell what charge that metal ion has by using the Roman numerals in parentheses. Sometimes it's easy, sometimes it's not. If you're not sure which transition metal ion you have, you might have to deconstruct or take apart the formula, go backwards, to figure out what its charge is. Let's do an example of that. Let's find the name of Ba3N2. Okay, Ba3N2. Now this is not a transition metal. Barium is not a transition metal. It's just a metal. So barium, that's the cation, the first thing I see, barium. The anion is from nitrogen, and nitrogen's called nitride when it forms an ion. So the anion is called nitride, and that means that the formula is called barium nitride. That's all I have to do. Notice I don't have the word tri in there for barium or di for nitrogen. I don't have to say that because when barium and nitrogen go together, they only go together 3 bariums and 2 nitrides. It's the only way it can work. Everybody in the world who knows how to write formulas knows that. So all you have to do is say the 2 ions. Okay? Let's look at this one though. Fe2O3. So Fe2O3, we want to name this. Now, normally we would just name the 2 ions. Well, the ion over here is called iron, and this ion is called oxide. The problem is you need to recognize that iron is a transition metal, and iron has more than one possible positive charge. So there needs to be, in parentheses here, a Roman numeral, which tells me what the charge on the iron ion is. And I can't tell just by looking at it. It's not a 2 necessarily, because that 2 is not what goes in here. It's the charge on the iron that goes in here. So I'm going to deconstruct the compound. I have 2 irons, Fe, Fe. There's my 2 irons. Right? I don't know what their charge is, so I'm going to leave it alone for now. I have 3 oxides. There's 3 of them. Each one is a -2 because that's what oxide's charge is. It's always -2, which means I have a total of -6 for my negative charges. I must, in order for this to be a compound, have 6 positive charges on this side. So the 2 irons together have to equal +6. Well, that must mean that each one is +3. And if each one is +3, then the Roman numeral that goes here is a 3. So this is iron 3 oxide. So it takes a little work, it takes a little practice. But writing the formulas is pretty easy as long as you know your charges. You just have to make them match. Writing the names, also pretty easy. Just be wary of the transition metals and make sure that you know what the charge on that metal ion is. Okay, we'll get some practice in class. Ask questions if you're not sure how to do it.